Hello everyone, welcome to the Physics Chronicles, and in this video we are going to talk about the coupled differential equations, how to find out the solutions of these differential equations like coupled systems, which is simultaneous differential equations. Remember, in this case the rate of change, there are more than one dependent variables but only one independent variable. For example of a coupled system or a coupled differential equation is, let me take dx by dt plus 5x minus 2y is equal to t. This is one equation, and another equation is dy by dt plus 2x plus y is equal to 0. If you see, there are two equations, and in each equation there are two dependent variables, that are x and y, and there is only one independent variable, that is t. And remember, in this case this rate of change of x with respect to t depends on x as well as y, and here the rate of change of y with respect to t depends on x and y as well. That's why we call this as coupled differential equations. Now, how to find the solution? Let me do this problem, and you can see how I am proceeding and do all the problems like this also. The same method will be used for all the coupled systems. So here we will take d by dt as capital D. And after taking capital D, this will be capital dx, and here 5x. So x take common. Finally, we can write down d plus 5 into x minus 2y is equal to t. And here also d by dt will be a capital D. Then the 2x remains as it is, and we can take common y from here and here. And after that we can write down 2 into x plus d plus 1 into y is equal to 0. Now, how we can proceed from here? We have to eliminate one of the dependent variables, either x or y. To eliminate y, we have to multiply d1 in this equation and 2 in this equation, so that these two will be cancelled if we add the both equations. Let me take equation 1 here and equation 2 here. Now let's multiply here d plus 1, then this equation becomes d plus 1 into d plus 5 into x minus 2 into d plus 1 into y is equal to d plus 1 into t. Don't worry about this RHS. This d is the differentiation with respect to t. So simply operate on t, this part. Then you will get 1 into t is t, and differentiation of t with respect to t will be 1. So this will give you t plus 1. And in the equation 2, multiply 2. Then you will get 4x plus 2 into d plus 1 into y is equal to 0. Now add both. After adding, this will be cancelled, and finally you will get, after doing the simplification here, you will get d square plus d plus 5d plus 5. So this will give you d square plus 6d plus 5, and here another 4 is there, so this will give you 9. Do this simple mathematics here. Plus 6d plus 9 into x is equal to, in the RHS I told you just now, you have to just operate this one on t. This will give you t plus 1. This is the equation we got. And you can see here, this is a second order linear non-homogeneous ordinary differential equation. And I have told you, in this case we have to find both complementary function and a particular integral. So let's find out this complementary function first. For complementary function, we will neglect this part. This will be equal to 0, and the auxiliary equation will be m square plus 6m plus 9 is equal to 0. This will give you m is equal to minus 3 and minus 3. That's why x complementary function can be written as c1 plus c2 into t. Here the independent variable is t. That's why we are taking t. E to the power minus 3t. This is the complementary function. And for particular integral, I told you to use operator method. You have to take this function of d to RHS. Then we can write down x into x particular integral 1 by d square plus 6d plus 9 and t plus 1. And this is first order polynomial. For first order polynomial or nth order polynomial, I told you to take the lowest term as common and convert this one into an infinite series, so that we can operate the operators on this polynomial. So what we can do, you just take this 9 as common, and after taking common, this will be 1 plus d square plus 6d divided by 9. And by taking to numerator, you will get 1 plus d square plus 6d divided by 9 whole power minus 1 operated on t plus 1. So if you open this one, this will be simply minus here, and no need to take higher order terms, because the higher order terms give you 0 here. This will be non-vanishing only for the first order derivative. Right, so we will get 1 by 9, 1 minus d square plus 6d divided by 9 on t plus 1. Right, and do the simple mathematics. This will give you a simple t plus 1, and here only this term will be there. Right, so this will give you simple 6 by 9. So you will get 1 by 9 into t plus 1 minus 1 by 9 6 by 81. 6 by 81, because 9 is there, multiplication will be say 81, and the differentiation will give you 6 here. And if we simplify this one, it will give you t by 9 plus 1 by 9 and minus 6 by 81. So if you add subtract both, then this will give you 1 by 27. Just subtract both terms, you will get the answer. And finally, we can write down x as a whole, c1 plus c2 into t e to the power minus 3t plus t by 9 plus 1 by 27. This is the complete function x. And then what you have to do, we have to take this x and substitute one of these equations. Any equation you can take. You will put x, and after differentiating, you will put dx by dt. You can simply find out the y here. Okay, so let's do that. I'm removing this equation because I will take only this one. So value of x is here. Find out dx by dt. Dx by dt will give you, so differentiation of this one and this in multiplication. So this will be c2 e to the power minus 3t minus 3 into c1 plus c2t e to the power minus 3t, and differentiation of t by 9 will be 1 by 9. That's it. Now take this and put here. You will get y as, take 2y to this side and t to this side. So y will give you 1 by 2 dx by dt plus 5x minus t. This is the value of y. Now you have to just substitute all these things and simplify. That will be your answer. So let me do one or two steps here. After that you can calculate. So dx by dt is c2 e to the power minus 3t minus 3 c1 plus c2t e to the power minus 3t plus 1 by 9. This is dx by dt. And 5 into x. So 5 into c1 plus c2 into t e to the power minus 3t plus 5t divided by 9 plus 5 by 27 minus 2t. This is the this is y. So you do the simplification, all these things I am leaving up to you, and after that you will find the value of y. So this is the total method. First we have to take d by dt as capital D. Then you have to eliminate one of the dependent variables from both the equations by adding and by multiplying some suitable terms. And after that you will find the value of one dependent variable x or y, and then use that and apply one of the given equations, put there, you will get the another dependent variable. So this is the whole method. You will use this one for all the coupled differential equations. Now let me take one question that was asked in JEST 2020 exam. So the last JEST exam, there was a question, very good question, very fundamental, very good question by using this coupled differential equation, and fortunately I could solve that. I didn't know how exactly proceed in these equations, but I could solve that in the exam hall. So yeah. So another example. This is JEST 2020 question, and the differential equations are given as. Let me see the question. Yeah. So the differential equation is given as dx by dt is equal to x plus y, and another one is dy by dt is equal to x minus y, I guess. Yeah. So he has given x dot 0 is equal to 0, and you have to find out the value x at t is equal to infinite divided by y at a t is equal to infinite. How much is this value? So the same method you have to use. You have to take d by dt as capital D and take this x plus y to this side and then eliminate. Let's proceed. So this will give you d minus 1 into x minus y is equal to 0, and this will give you d plus 1 into y minus x is equal to 0. Now what you have to do, you have to multiply d plus 1 in this equation, and no need to multiply anything in this equation. So here I am taking 1 and taking this one 2. So equation 1 into d plus 1, this will give you d plus 1 into d minus 1 x minus d minus 1 d plus 1 into y is equal to 0, and equation 2 is as it is. So d plus 1 into y minus x is equal to 0. So you can see this term and this term will be cancelled if you add both the equations, and finally you will get d plus 1 into d minus 1, that will give you d square minus 1 into x minus x is equal to 0. This is the equation you got. Now there is minus 1 and here is also minus 1, so this will give you d square minus 2. So here you have d square minus 2 into x is equal to 0. Now you have to find out the complementary function. No need to find a particular integral because there is nothing on the RHS. So you can write down x of t is equal to, here by solving this one, this will give you m square minus 2 is equal to 0. So m will be plus or minus root 2. So x of t will be c1 e to the power root 2t plus c2 e to the power minus root 2t. Right? And then I told you, you have to find out the derivative of x with respect to t and put one of these equations. Now let's find out this dx by dt is equal to root 2 c1 e to the power root 2t minus root 2 c2 e to the power minus root 2t. This is the dx by dt. And let's put these both in this term. So we will get y is equal to dx by dt minus x. So this is dx by dt and this is x. If we subtract, we will get root 2 c1 e to the power root 2 t minus root 2 c2 e to the power minus root 2 t minus c1 e to the power root 2 t minus c2 e to the power minus root 2 t. Now what we can do, we can take this c1 e to the power root 2 t term as common. Okay, root 2, here root 2 and here minus 1, and c1 e to the power root 2 t as common, and from here you can take a minus common. If you take minus common, then it will be root 2 plus 1 c2 e to the power minus root 2t. So this is the value of y. Here is x, here is y. Now what you have to do, there is a condition, that is x dot of 0 is equal to 0. So if you apply here, what we will get, this will be 0 at as t is 0. So this will be 0, this will be 1, this will be 1. So this will give you, let me do that. Yeah. Okay, so he is given dx by dt at t is equal to 0 is 0. Now let's put that here. This will give you 0 is equal to root 2 c1 minus root 2 c2. That's implied c1 plus c2. Let's say this is c. Let's assume as c. Now what you can write down, x is equal to c e to the power root 2t minus e to the power minus root 2t, and y is equal to c root 2 minus 1 e to the power root 2t minus root 2 plus 1 e to the power minus root 2t. Right? Then he is asking the ratio of x at t is equal to infinite and y at t is equal to infinite. He is asking this one. Now let's just divide both these things and see how we can proceed. The ideas should come to your mind. So this will only happen if you solve some good problems. By practice, the ideas will automatically come to your mind. So just divide x by y. You will get c will be cancelled. You can see, and this one e to the power root 2t minus e to the power minus root 2t divided by root 2 minus 1 e to the power root 2t minus root 2 plus 1 e to the power minus root 2t. Right? Now see, he is asking x at t tends to 0 and y t tends to 0. So if you put directly here infinite, then e to the power infinite will be infinite. So you cannot find. But e to the power minus infinite gives you 0. So you have to convert this into only in the terms of e to the power minus t term. So how you can find it? You can just divide e to the power minus root 2t everywhere in numerator and denominator. If you divide, then this will become 1 minus this will become e to the power minus 2 into root 2t. Similarly, in the denominator, this will be 1. This will give you root 2 minus 1 minus root 2 plus 1 e to the power minus 2 root 2t. Now you can put x at t is equal to infinite and y at t is equal to infinite is equal to 1 minus e to the power minus infinite will be 0, and here root 2 minus 1 minus root 2 plus 1 and e to the power minus infinite. So this will also be into 0. So finally you got 1 by root 2 minus 1. Check the options if this term is there. If not there, you can simply simplify by multiplying root 2 plus 1 on the numerator and in the denominator. So root 2 plus 1 divided by root 2 minus 1 into root 2 plus 1. That implies this will give you a square minus b square. So 2 minus 1 is equal to 1. This is root 2 plus 1. This is the answer. Right. So these ideas should come to your mind. Okay. So that's it for this video. I told you how to find out the solutions of coupled differential equations and solve the previous JEST question. And we will see in the next video some new concepts and the examples associated with that. So till then, stay home, stay safe, take care of your family, and bye bye.